Good morning, students. In the last class, we discussed about the periodic properties. In the first periodic property we discussed is atomic radius. Okay, we discussed the types of radius, even the comparison between the different types of radius, as well as the variation of ionic radius in the isoelectronic species also. Right? Now, coming to the variation of atomic radius along the groups and the periods. It is writing as variation of atomic radius or atomic size along the groups and the periods. Before discussion about the variation of this atomic radius along the particular group or period, first we need to know based on what factor we can say the element will have large in size or small in size. Okay, there are mainly two factors which affects the atomic radius. So remember this. The atomic radius is mainly depends on two factors. One is number of shells. Okay, number of shells nothing but number of orbits. Okay, the main factor which affects the size of the atom is mainly the number of shells present in the atom. Okay, a simple thing to understand also, because and the atom is having one shell, one orbit, have some radius. Now, if the number of shells are increasing, so automatically what happens? The size of the atom also increases. Okay? As the size of the atom increases, the radius of the atom also increases. So remember this main point, atomic radius. It is mainly directly proportional to the number of orbits present in the atom. Okay, and it is directly proportional means what? As the number of shells increases, atomic radius also increases. Okay, and one more important factor which affects the atomic radius mainly is nuclear charge. Yesterday in detail we discussed about this one. What is the effect of nuclear charge? We know when the nuclear charge is more, it attracts the outermost electrons strongly towards it. So the electron cloud moves close to the nucleus. So size of the atom decreases. Okay? So when the nuclear charge is more, atomic radius will be less. So that's why we can say simply atomic radius is inversely proportional to the nuclear charge. Okay? So, if the out of the two atoms, yesterday we discussed, in case of comparison of radius between the atom and the cation. Okay? So, in the case of cation, nuclear charge is more. That's why cation is having small size compared to the parent. Okay? So, remember these two factors. Now, based on these two factors, now let us observe the variation of this atomic radius in the groups and the periods. Now first coming to the groups. Variation of atomic radius in the groups. In the groups means what? These vertical columns, those are known as groups. And I already told you in what we will observe the variation. In the groups we will observe the variation from top to bottom. Okay? It is very easy to say in the groups, as you are moving from top to bottom, atomic radius increases. Okay? From top to bottom, the atomic radius increases. Why it increases? Because as we all know that when we are going down, atomic number increases. Even if you observe the period number increasing, nothing but number of orbits also increases. For example, if you observe hydrogen, hydrogen has only one electron in the first orbit. Coming to the next element in the group, lithium, it will have 2s1. Means it is having two orbits. Hydrogen has only one orbit. Lithium has two orbits. Sodium, if you observe, have 3s1. So means it will have three orbits. Okay? So in the groups, it is very easy to say that from the top to bottom, the atomic radius increases. The reason behind that is the number of shells increases. Okay? Write that point. In a group, from top to bottom, atomic radius, from top to bottom, atomic radius increases. Okay? What is the reason behind that one? Why the atomic radius increasing? Because the number of shells increases. Okay? As we are moving down in the group, the number of shells increases, the atomic radius also increases. This is in the case of groups. Now coming to the various atomic radius in the case of periods. Now in the case of periods, in what direction we observe? In the periodic table from left to right. Okay? So the variation in the periods we will observe from left to right. Once if you observe that in a period, all the elements will have same number of shells. Because the period number represents the number of shells present in the atom. So whatever the number of elements are there in the period, we have same number of orbits. Previous case, we said as the number of shells increases, atomic radius increases. But coming to the periods, here all the elements in a period will have same number of shells. Can we say all will have same radius? No. Okay, so if you observe the second period in the periodic table, we know the starting element of the second period, lithium. Okay, next beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. Okay, so if you observe these elements, all these contains the electrons in first and the second periods. So all these elements contains only two periods. But if you come observe the nuclear charge, so what is the atomic number of lithium? Is 3. So it contains 3 protons. Carbon atomic number 6, it contains 6 protons. Fluorine 9, so 9 protons. Okay. So as you are moving from left to right in a period, the number of shells may remain same. But what is the difference here? The nuclear charge increasing. Okay. There we already discussed it. As the nuclear charge and atomic radius are inversely proportional. So, as the nuclear charge increasing, atomic radius decreases. Okay? Because nuclear charge increasing means it attracts the electron cloud very strongly towards it. So that is why in a periods, as we are moving from left to right, atomic radius decreases. The reason is the nuclear charge increases. In periods from left to right, the size of the atom decreases. Okay, from left to right, the atomic radius decreases in the periods. Reason is what? Due to increase in the nuclear charge. Okay, in the periods as we are moving from left to right, atomic number increasing, so nuclear charge increasing. As the nuclear charge increases, atomic radius decreases because both are inversely proportional. Okay, but in the group, there also atomic number increasing, but along with that, the number of shells increases. But in the case of period, the number of shells remains same. Okay. Note down these two. So finally, regarding the atomic radius, we need to remember 2 points about the variation. In the groups, atomic radius increases from top to bottom. In the periods, atomic radius decreases from left to right. Okay. Now regarding this atomic radius, we have an important thing like lanthanoid contraction. Lanthanoid contraction. About this lanthanoid contraction, and then let us discuss in F block elements lesson in detail. But anyway, we are discussing about the variation in the atomic radius. That is why let us discuss briefly about this one. A contraction, yes, everyone knows that decrease, okay, or reduction. In the case of lanthanoids, if you observe, lanthanoids means from which element to which element? Lanthanoids are from lanthanum to lutetium. Okay? The elements followed by lanthanum up to lutetium. So these elements are known as the lanthanoids. We all know about that. In the case of lanthanoids, the atomic radius or the ionic radius decreases steadily from lanthanum to lutetium. Okay, that steady decrease in atomic radius or ionic radius of lanthanoids is known as lanthanoid contraction. Okay, the same thing we will observe in the case of actinides also. So that is known as actinide contraction. Right? Here, the main thing we need to discuss is why we are observing this lanthanide contraction. Okay, the main reason behind the lanthanide contraction is due to the poor shielding effect of F orbitals. Okay, till now we did not discuss about the shielding effect. So that is why even furtherly when we discuss about ionization potential, we will discuss about shielding effect. Right? Regarding the reason for this, we note down anyway in the F block elements lesson. This is only our main topic. Okay. So what is lanthanide contraction? What are the consequences of lanthanide contraction? We will discuss in the F block elements lesson. Okay. So first you note what is meant by lanthanide contraction. It is nothing but the steady decreasing atomic and ionic radii of lanthanides. Okay, the steady decrease in the atomic and ionic radii of lanthanoids is known as lanthanide contraction. Okay, what is the reason behind this lanthanide contraction? Means due to poor shielding effect of F orbitals. Okay. So what is shielding effect? Everything we will discuss in the next periodic property. Right? About the consequences of this one, in what way it affects, everything we will discuss in F block elements lesson. Right? Note this. Now, coming to the next periodic property, a very important periodic property, that is ionization energy or ionization enthalpy. Okay? The second and most important out of all the periodic properties. As I told you, atomic radius is one of the important one, because to understand the next periodic properties, atomic radius is very important. Even to know the nature of the compounds, so nature of bonding between them. To understand all those, that atomic radius is very important. But coming to the competitive exams point of view, this ionization potential or ionization energy is a very important periodic property, because many applicable questions they are asking based on this ionization energy. Okay, even this is also known as ionization energy, is also known as ionization potential. Okay, anything is same. The ionization energy, or it is also known as ionization enthalpy or ionization potential. Okay, ionization energy in small way they will represent as IE. Ionization potential is represented as IP. Okay. Now coming to the definition of ionization energy. In a simple way, we discussed in atomic structure lesson also. Even from the definite statement, heading also will come to know. Ionization means what? What is meant by ionization? Generally, we know. In the case of ionization of hydrogen atom, we discussed, right? When we remove the electron from the atom, then it gets charged. So that is known as ionization. Okay? Energy. Generally, to remove anything, definitely it requires some energy, right? For example, I am holding the chalk in this hand. To take the chalk from this hand, definitely it requires energy. So the energy required to remove the electron from the outermost orbit of an atom is known as ionization energy. Okay? Because if you place an electron in the outermost orbit, definitely to take it, practically we know it requires some energy, right? So when it requires more energy or when it requires less energy depends on many factors, correct or not? Because while taking the chalk from this hand, if this hand holds this chalk strongly, how can I take easily? I have to apply more amount of energy, right? So there are many factors to affect ionization energy. Those are very important. So first let us discuss about the definition. What is meant by ionization energy? Then we will discuss about the factors which affect ionization energy. So first coming to the statement, definition of ionization energy. It is nothing but the amount of energy required to remove an electron from the, remember this point, from the outermost orbit. Okay, so while we are going to remove the electron, from where we have to remove the electron first? We should remove the electron first from the outermost orbit, not the second orbit or not the third orbit. We should say it is the outermost orbit. Okay, so the electron will be first removed from the outermost. If you remove all the electron from the outermost, then only we can remove from the inner orbits. Okay. So now coming to the ionization energy, the amount of energy required to remove not under the influence of other atom. Isolated gaseous atom. Right? So ionization potential or the ionization energy nothing but the amount of energy required to remove an electron from the outermost orbit of an isolated gaseous atom. Okay? Note on this. See, as an example, the ionization energy I am going to represent like this. For example, I have taken an element M. So when we remove an electron from this, so what will be its charge? M charge will become +1 because one electron was removed. Okay? So this process is ionization and the corresponding energy required to remove this electron is known as ionization energy. Okay? Also ionization potential. Okay? Even generally ionization energy nothing but first ionization energy. There will be some successive ionization energies. For example, if an element has 10 electrons, so there will be 10 ionization energies, right? If an element has 15 electrons, then we will have 15 ionization energies. Okay? Now, let us discuss about what is meant by second ionization energy. Second ionization energy means we can represent it as IE2. Okay? The first one, whatever the definition we discussed, that is IE1. Now coming to second ionization energy. Now, it is also the amount of energy required to remove an electron from the outermost orbit of an unipositive ion. Okay? So let's observe the definition whatever you written for first ionization energy. And now compare the definition of second ionization energy with this. You will find only one difference. That is, in the case of first ionization energy, we are saying that the amount of energy required to remove an electron from the isolated gaseous atom. Atom means we need to say neutral in charge. Okay, so that is why I did not mention it as a neutral atom. Okay, because in some books they may give it as a neutral atom. Don't confuse them. Atom means indirectly it is a neutral. Okay, because the atom don't have charge. If the atom having charge means we call it as a ion. Okay, but in the case of second ionization energy, in what way we define the same thing, the amount of energy required to remove the electron from which one? From the unipositive ion. Uni means how many one? One. So the ion having 1 unit of charge. So from that ion, if you remove one more electron, okay, so from this ion, what is this ion? This ion is known as unipositive ion. I hope you understood the name. Uni means one. Okay? So the the ion having 1 unit of positive charge. How you got this 1 unit means already 1 electron is removed. Okay. So now from this, if you remove 1 more electron, the corresponding ionization energy is known as the second ionization energy. Okay. Got the definition of it? Now, for example, if you remove 1 electron from this, what will be its charge? Okay. So when you remove 1 electron, 1 positive charge increases. So from this, when you remove 1 more electron, now it will become M plus 2. Okay. Now, for example, coming to third ionization energy. I hope now you are able to define this. How can we define third ionization energy? First ionization energy we defined. It is regarding the removal of electron from the atom. Second ionization energy is regarding a unipositive ion. Third ionization energy corresponds to what? To remove the electron from the dipositive. So already removed 2 electrons. Now if you want to remove 1 more electron, the required energy is known as third ionization energy. Okay? So definition wise, the amount of energy required to remove electron from which ion? This one. Previous one is unipositive because its charge is +1. But now in this case its charge is +2. So it is called as dipositive ion. Okay. So ionization, third ionization energy is nothing but the amount of energy required to remove an electron from which one? From the dipositive ion. Okay, dipositive ion means ion already having 2 units of positive charge. Okay, that means already 2 electrons are removed. Now to remove the third electron, how much energy is required? That is called third ionization energy. Okay. If you want to remove 1 more electron, fourth electron, there will be fourth ionization energy. Next to remove that electron, fifth ionization, like that it will go on. Okay. For example, if I ask you that for a particular element, how many ionization energies are possible? I already told you, for an atom, the number of ionization energies is nothing but its atomic number. Okay. So mention it in the notes. The number of ionization energies of an atom is equal to its atomic number. Right? For an atom, the number of ionization energies is equal to its atomic number. Okay? So, I hope you all came to know that what is meant by first ionization energy, second and third, fourth, fifth, like that. Now, coming to the exam point of view, the main question is the comparison between the first ionization and the second ionization. Okay? So, let us discuss that first. First, note down this. Okay, the subheading is comparison of ionization energies of same element. Okay, we are not going to compare the ionization energies of one element with the other element. To compare that, first we need to know some factors which affects ionization energy. And now here we are going to discuss about the comparison of ionization energies of the same element. Like the comparison between first ionization energy and the second ionization energy. Let us observe. Okay? It is a very easy thing. Now, first ionization energies corresponds to which one? To the element or to the atom or to a neutral one. But this one is corresponds to the ionization energy of that element when it is having plus one charge. Okay? For example, now I have to ask you, what about the nuclear charge? What about the effect of nuclear charge on the outermost orbit of these two species? Okay? Because in a neutral atom, this is a cation. Yesterday we already discussed regarding the size comparison. In this case, one electron was less. Nothing but effective nuclear charge on the outermost orbit is more. When the effect of nuclear charge is more on the outermost orbit, then what happens? All these electrons will be tightly held by the nucleus. Okay? Let us observe. For example, an element is having 10 protons in the nucleus. So it will have some nuclear charge. So it will hold the electrons with some nuclear charge. So then the amount of energy required to remove that is the first ionization energy. Now, our question is to remove one more electron, whether it requires more energy or less energy. Right? For example, one was lost easily, let it be. Now, if I want to remove one more, the nuclear charge is more because the number of electrons is less. One electron is less or not. Even if we go for third ionization energy, here two more electrons are less compared to the first one. Okay? Indirectly what we can say? In this case, the protons number is more than electrons. Okay? So what happens then? All the electrons will be strongly held by this nucleus. It attracts very strongly towards it because the number of protons is more. So positive character is more than negative. What happens? All these negatively charged electrons will be strongly held by the nucleus. Then, if you want to remove the electron, we have to apply more amount of energy. Okay, it is very easy thing to understand. So that's why finally what we can say, in any element, the first ionization energy is a smaller value compared to the second ionization energy. Okay? Even the second ionization energy will be smaller than the third ionization energy. Okay? Even if we go for fourth comparison, definitely it requires more energy to remove the fourth electron compared to remove the third electron. Because when electron is removed, the effective nuclear charge will be increases. Okay? Even the electrons will be very strongly held. So it requires even more energy to remove the fourth electron compared to the third electron. Okay? So for any atom, the variation of ionization energies if you observe, the second ionization energy is more than first ionization energy. In the same way, third ionization energy more than second, fourth is more than third. Okay, so no exceptions and nothing. In any element, this order is same. Okay, so IP5 they ask, that will be greater than IE4. Okay, Sixth ionization is more than fifth ionization, like that. Okay? Note of this. So now we discussed about what is meant by ionization energy. Regarding the values, energy means we can express in terms of joules or calories. That is quite common thing. Even we can express the energy in terms of electron volts also. Mentioned in the notes about the units. Ionization energy can be expressed in terms of joules per atom, or it can be expressed in terms of calories per atom, or even we know kilojoules per atom or per mole. Per mole means you got idea. This is energy required to remove electron from 1 mole of atoms, or kilocalories per mole. The most common and the important way to express it is electron volts per atom. In the atomic structure lesson, we solved some numericals also based on this ionization energy. Okay, there also we use the units mainly as electron volts. Okay, one electron, for example, how to convert electron volts to joules also we discussed in that lesson. One electron volt is nothing but how many joules? It is 1.602 into 10 to the power minus 19 joules. Right? So remember the units to express ionization energy. Now coming to the important one, that is factors affecting ionization energy. Okay, and starting also I told you to answer the questions related to ionization energy, we should have clarity about which factors affects the ionization energy in which factor. Okay. Then after this discussion, let us solve some different models questions, whatever the way they are asking based on the ionization energy. Okay. When you have clarity about these factors, how they are affecting, then you will begin the question to solve the question. Okay. So if you observe the factors which are affecting this one is, the first factor is atomic radius. Now the second factor is nuclear charge. So these are the main two factors which affects the ionization energy value. Along with these, there are some other also, like screening effect, or it is also known as shielding effect. Getting the Lambda contraction, as I already told you, this is the reason for that. So first let us discuss what is meant by this. Even the other factors like penetration effect of orbitals, and the last, even electronic configuration also. Because we know regarding the electronic configuration, when the element is getting half filled or completely filled electronic configuration, it is getting some extra stability. So in such cases also, the ionization energy will be changes. Because when the element is stable, is it want to lose the electron? No. Every one of us don't wants to lose our stability. Right? So the atoms also in the same manner. When they are stable, they don't want to lose the electron. When they are not ready to lose the electron, we have to apply more amount of energy to remove the electron. Okay? So in what way all these factors affect individually, let us discuss. So first note down this. Let us discuss about the effect of atomic radius on the ionization energy. Okay? A very easy thing to understand. First look at here. We have an atom with the large size and we have an atom with the small size. Okay? Now our comparison is between the ionization energies of the large atom to the small atom. When it will be easy to remove the electron, when it will be difficult to remove the electron, we should know. Okay? Now tell me, out of the two, in which case you feel it will be easy to remove the electron? The smaller one or larger one? Okay? See, how can we come to know the smaller one or larger one? If you observe here, larger the atomic size, automatically larger the atomic radius. Okay? Nothing but the distance from the nucleus to the outermost electron. This is our outermost electron. In this case, this is our outermost electron, and this is the atomic radius. Okay? So in the case of the small one, the distance from nucleus to the outermost orbit is less. Okay? As the distance from the nucleus to the outermost orbit is less, nothing but indirectly we can say the effect of this nucleus is more on the outermost electron. Okay? In this case, larger the size means what? The number of shells will be more. So the distance between the nucleus to the outermost electron is more. Okay? It is far away from the nucleus. So automatically the effect of nucleus on that electron will be less. Okay? So this electron cannot be strongly attracted by the nucleus. But in this case, the smaller the distance, effect of nucleus is more. So the nucleus strongly attracts the electrons towards it. So in these cases, to remove the electron, it requires more amount of energy. Okay? So smaller the size, ionization energy is more. Larger the size, ionization energy is less. Okay? So in simple manner, we can say that atomic radius is inversely proportional to ionization energy. Okay? As atomic radius increases, ionization energy values decreases. Okay? Reason what? As the atomic size increasing, radius also increasing. So the effect of nucleus of the outermost orbit decreases. Okay? When the effect of nucleus is less, we can remove the electron from the outermost orbit very easily. Okay? Means by applying less amount of energy only, we can remove the electron. So remember this point. Okay? Smaller the size, more will be the ionization energy. Okay? Now about the other factors which affects ionization energy, let us discuss in the next class. Thank you.